few seconds. Please on your camera. Before we start, let's recite Al-Fatiha. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Ar-Rahmanir-Rahim. Maliki Yawmiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Right. After last time we looked at the real zeros. Now we're going to look at the complex zeros of one polynomial. Complex zeros of one polynomial. Remember that one polynomial given one polynomial, not necessarily that the zeros of that polynomial are real. We may have the complex of zeros of polynomial. So when we talk about complex zeros of polynomial, we have one theorems which we call conjugate pair theorem. Conjugate pair theorem say that if one complex number z, a plus bi, is a zero of polynomial px, then its conjugate, which is represented by z bar, a minus bi, is also zero of polynomial px. So if you look at these theorems, we can see that zeros of polynomial for complex zeros, now we're talking about complex zeros of polynomial, they must come in even number. Because of the conjugate pair theorems, they don't come in 1, they don't come in 3, they don't come in 5, they will come in 2 or no, or 2 or 4 or 6, because of pair. Conjugate pair theorems. If you remember that the last of the examples of last week, where we want to find the zeros of polynomial that I gave to you, zeros of polynomial. So that polynomial, remember that the last examples of last week, how many zeros of that polynomial? For last time, for the last examples, have you got the note for the last examples that I give to you? How many zeros? How many zeros for that polynomial? For the polynomial, how many zeros? Last examples. Last examples. Can you see that as examples? How many zeros?
2, sir.
No. All the zeros. 2 is real. And all the zeros. How many zeros? How many zeros?
3, sir. 4.
4 zeros. 4 zeros of that polynomial. And 2 of them, as we found, real. So how many of complex?
2, sir.
2. That's why you see that. Because of the conjugate pair theorems. Conjugate pair theorems. That's why complex zeros on the examples come into. Because of the pair. That's definitions here. Conjugate pair theorems. So Let's say examples here. If 1 plus 3i is a zero of polynomial px, which is x to the power of 4 minus 3x to the power of 3 plus 6x to the power of 2 plus 2x minus 60. Find all zeros of px. How many zeros altogether for this px, for this polynomial? Px is polynomial. How many zeros altogether? 4 zeros. And 1 zero is given. 1 plus 3i is a 0. Meaning what? We're using conjugate pair theorems. Meaning what? Meaning what? Meaning what? Meaning what? What does it mean by that? Using conjugate pairs theorems. What does it mean by that? If 1 plus 3i is a 0, so we have 4 zeros for this polynomial. 4 zeros. 4 zeros. But how many zeros we already know? How many zeros we already know?
2.
2 zeros. Okay.
1.
1 zeros we already know. Yes. But definitely we will know that 2 zeros. Why? Why we know the 2 zeros? Why definitely we will know 2 zeros? Why?
Conjugate also 0.
Conjugate pairs theorems. So another 0 will be
1 minus 3i.
1 minus 3i. So zeros that we have here, 0x minus 1 plus 3i. 1, right? Another 1, x minus 1 minus 3i. This is zeros. Zeros of polynomial. Zeros of polynomial. And we need to find 2 more zeros. Why we need to find 2 more zeros? Because this polynomial have 4 zeros. 2 zeros, we already know that this. They are complex. How do we know another remaining 2 zeros? How do we get? We get 2 zeros by dividing this polynomial by what we have from these 2 zeros. We divide. So when we write this, we write back is x minus 1 plus 3i x minus 1. Sorry, here is minus x minus and plus minus x minus 1 plus 3i. Why we need to expand this? Because we want to know what is the polynomial that we want to divide with this in order for us to find the remaining 2 zeros. You get it? We want to find two more zeros. Two zeros we already have. 1, 2. We want to know another two zeros. And the process of finding two zeros more, we need to divide our polynomial with this polynomial, a small polynomial. Small polynomial here we can obtain by substituting zeros. You get it? So what do we get when you multiply? When you multiply this, what do you have? You multiply 1 by 1. X minus 1 multiplied by what? X minus 1 multiplied by what? Can you multiply this? Can you multiply this? What? How do you multiply? Oh, you multiply this. How do you multiply this? How do you multiply this?
Multiply it 1 by 1.
So let's like this. So x minus 1 multiplied by what?
X minus 1 and 3a.
X minus 1 multiplied by x minus 1. Minus plus, yeah. Only now, our a is x minus 1. That's why I always say when students always cannot see in this term. But when we draw or when we give example in this, imagine this is A, this is B, this is C, this is D. When you imagine this is multiplied by this, and then multiplied by this, and then multiplied by this, and then multiplied to of this. So, nothing difficult. So, x minus 1 multiplied by what? Multiply by what?
X minus 1.
So, x minus 1 multiplied by x minus 1, we will get x minus 1 square. And then x minus 1 multiplied by
3i.
So we get x minus 1, 3i. Then here, minus 3i multiplied by x minus 1. What we get?
Minus x minus 1, 3i.
3i. Minus 3i multiplied by 3i. Minus
9i
squared.
out.
9i squared. So here will be cancelled. Definitely cancel. So we get x minus 1 square minus 9 minus 1. I square is minus 1. So we get x minus 1 square plus 9. Expansions of x minus 1 square, we will get x square minus, what is the expansions of that?
2x
2x
plus 10.
plus 10. X square minus 2x plus 10. So This is small polynomial, so we divide big polynomial by small polynomial. Which divisions we have to use? Which divisions? Which division we have to use in order to divide this? Which division? Which division?
Long division.
Long divisions. Why we cannot use? Why we don't use certain divisions? Why we don't use certain division? Why we use long divisions? Yes, use long division, but why we use long divisions? Why we don't use certain divisions?
Because the x will be 1.
Because the power of x is supposed to be 1. If the power of x is not 1, we cannot use simple division. So we use long division. X to the power of 4 minus 3x to the power of 3 plus 6x squared plus 2x minus 60 divide by x squared minus 2x plus 10. So the first one, how do you get that? The process of long divisions method. What do we do first?
X power of 2.
X power of 2. Why x power of 2?
When we x power 2 times with x power 2, we can cancel the x power of 4.
Another way. Why we choose x power of 2? Yes, x power of 2, but why? Why x power of 2?
X to the power of 4 divided by x to the power of 2.
X power of 4 divided by x power of 2. So we have x power of 2 and we have x power of 2. We have to write here. This color for x power of 2. X power of 2 times x power of 2, x power of 4. And then
Negative 2x power of 3 plus 10x the power of 2.
okay. Cancel. Minus x to the power of 3 minus 4, 4x squared. Bring this plus 2x. Then what we have? Then what we have?
Minus x.
Minus
X.
So minus x power of 3. When you multiply. Minus what?
will be positive 2x power of 2
Okay.
minus 10x.
Ah. So 2x plus 2f bring minus 60. Then is it 2x here?
86.
56, right? 56. 56. Then what?
Positive 12x.
Positive 12x
Minus 60.
minus 60. Then finish. So our px infactored form is going to be x minus 1 plus 3i. 1 of the 0. Always 0, x minus that 0. X minus another 0, another 0. What is another 0?
1 minus 3i.
1 minus 3i. Another one? This. X squared minus x minus 6. Because this is represent of the x. This is represent of qx. And our x is 0. So when we factorize x squared minus x minus 6, so what we get is what?
X minus 3,
X minus 3,
x plus 2.
x plus 2. Therefore, we have 4 zeros. One zero, 2 zeros, 3 zeros, 4 zeros. And from 4 zeros here, 2 of the zeros real. And 2 of the zeros complex. So, because the question say find all zeros. You look back at the questions. Find all zeros. So, zeros will be 1 plus 3i. Another one. Another one.
One minus 3i.
1 minus 3i. Next.
3 negative 2.
3 minus 2. 4 zeros. Of this polynomial. And remember that those 4 zeros the combinations of real and complex. Combinations with real and complex zeros. The questions. Find the complete factorization and find all the zeros of this polynomial. First, we need to factorize. How to factorize it? How to factorize it? Because after factorization, we can have the zeros. How to factorize it? How to factorize it?
X minus 3, x plus 2, minus 2.
X minus 3,
X plus 2,
x plus 2,
x minus 2.
x minus 2. How did you get that?
Factorize using calculator.
This is wrong. Are you trying to factorize without using calculator?
Using calculator, sir.
Huh? Try not to use calculator. Try to factorize by not using calculator. This is wrong, right? Try to factor without using calculator. Because without using calculator, make your brain working. Make your brain working and easy to show. The problems when everything can do using calculator, that's the problem now. Because modern calculator can do everything. Even to when we study mathematics, this is talk about mathematics 3, right? Calculator can show what is the answer. So what techniques we use in order to factorize? And because your paper mark will be given for the way you get it. So you must have a few steps to get it before you go to the final. So what's the methods you use in order to factorize this? I remember that last of the examples last time. Example of last week. What methods that I use to factorize? Remember that one we have to factorize. So what methods we use?
Remainder theorem.
No, remainder theorem. No. The methods of factorizations of this.
So can we use long division?
No, nothing to do with long division. To factor. What methods I use to factor? Remember, look at the last examples of last week. I think last week, the last lesson is on Friday, I think. And the last examples, if I'm not mistaken, find all the real zeros. Right.
Discard saja, discard.
No. This guy find all the real zeros, right? The last examples. C, part C. This cut is part A. Remember that we have three parts. Last example, we have three parts. Part A is discards. Part B, list of possible rational zeros. Part C, remember that lesson last time?
Synthetic division.
Eh? Have you got with you the note? No?
Yes, sir.
If you got with you, what is the last one?
Synthetic, sir. Synthetic division.
No, I
Synthetic
want
division.
factor. When I factor, what I use to factor? We want to factor, right? So what I use to factor?
Synthetic division.
It's nothing to do with the division. To factor.
Sir, the answer is x squared plus 4 multiplied by x minus 3.
But how do you get that?
Factorize.
QX dx saja.
No. Factorizations. How to factor? I say to you, remember, listen here. Factor by grouping. In that term of factor by grouping, you know. I get it last time. So factor by grouping, one group, right? It's nothing to do with the division. Factor by grouping. So here, what is the common factor for the first one?
X power.
X squared.
What is the common factor for the first one? Common factor here.
X squared.
X squared. Right, now we want to produce x power of 3. So what we have to do?
X multiplied by x minus 3.
No, we want to produce this one. We want to produce this one. What do we have to do?
X minus
3.
We want to produce this one first. This one.
Oh,
What do we have to
X.
do?
X.
X. Then we want to produce this one. What do we have to do?
Minus 3.
Minus 3. Yeah. We go one by one. Okay, plus. Then we go to the second term here, right? So which one did they share? They share. The one they share, we have to put it outside to make a common factor. What they share?
4.
So to produce for x,
X.
to produce minus 12,
Minus 3.
Minus 3.
Like that. So remember, always remember that when we want to factor, you can have using calculator. I think you can have straight. This is the methods. So we have marked that. Since x minus 3 same, so we can make x squared plus 4 times x minus 3. Correct. But this is correct. But I want to know why you get it, because one of the answer that you give to me, x squared plus 4 times x minus 3. Yes, correct. But how do you get that? This is the way you get it. Or we can write the x minus 3, x squared plus 4, right? Or we can have like that. Okay. This polynomial have how many zeros?
3.
3 zeros. Therefore, 1 0 we get from here. 2 zeros we get from here. And from here, definitely real. From here, from here.
One real or not?
From here, real. From here,
Complex.
Open number.
you can see that. X squared plus 4 equal to 0. We make equal to 0. Because 0 is make the polynomial 0, so we want to make 0. X squared equal to minus 4. X is plus minus square root of minus 4. X is what? X is what?
2i.
Plus
Plus
minus
2i.
2i. So zeros we have here. Because this question want to find zeros. Zeros are what? Zeros are
3,
3,
2i,
2i,
negative i.
minus 2i. 3 zeros. And this is real. These two complex. Remember that at the beginning of the lessons today, I said that complex zeros, they must come in pair. That's we call conjugate pair theorems. You can see here. Come with 2. Maybe 4. Maybe 6. Depends. But not come in odd number. Not come as 1, 3, 5, etc. Questions? A break for 5 minutes. Right. Welcome back. Ready to continue?
Yes, sir.
Okay. So tutorial one, you submit through WhatsApp. But not for personal WhatsApp in the group, class group WhatsApp. For tutorial one. Right. And let's say we have different polynomial functions. The x is 2x to the power of 5 plus 36x cubed plus 162x. Complete factorizations as well. And also from that, find all the zeros. Factorize. So now we have three terms instead of 4 terms. We cannot use factorizations by grouping because we cannot group 2 and 2. So what we have to do, all those 3 terms here, term number 1, term number 2, term number 3, they share what? What they share here?
X.
X and also
2x.
2. So make 2x as a common factor. X to the power of what?
4.
4 plus
18
Plus?
X squared.
18x square plus
81.
81. Right. 2x, to factor this part, we use factor by substitution, where we let u square equal to x to the power of 4. We let u square equal to the power of 4. Therefore, here become u square plus 18u plus 81. U square plus 18u plus 81. Since we change for a while, temporary change. For x square here, we make x power of 4 here, we make as u square. So we change x power of 4 to become u square, x power of 2 to become u only. Or you can say that u is equal to x to the power of 2, same. Same as u square equal to x to the power of 4. Plus 81, now we can factorize this as what? U can you factorize?
U plus 9,
U plus 9,
U minus 1.
U minus 1. if you put u minus 1, you try to expand again. Have you got this? The way you get the number here is you expand those numbers, you will get back this.
Oh, sorry sir, u plus 9 also.
U plus 9 also. When you expand, you get this. So what is u? U is, and now we start to change again.
X square.
X square. X square plus 9. X square plus 9. Therefore, our px can be written as 2x, x square plus 9, x square plus 9. Understand? And now, our px in this infected form look like this. Look like this. And the process of factoring this, definitely we need to use u as temporary use. We use temporary. When we get back, we go back to change. We can solve it, go back to change it to x again. Because we don't want u, we want x. Correct. So, from here, we get 1 0. 1 0. From here, we have how many zeros?
2.
2 zeros. From here,
2.
2 zeros. 2, 2, 1, 5 zeros. So from here, x squared plus 9 to know 0, make x squared plus 9 equal to 0. X is plus minus 3i. How do you get this? Any question how to get this?
Complete number.
So how do you get this? Do you know how to get this?
X squared
Square root 9.
X squared
square root 9. Square root negative 9.
9.
So same as this. From here, because these two same. How we get this? Therefore, zeros are, what are our zeros? What are our zeros? What are our zeros?
1/2.
1/2.
0.
0.
3i.
3i
3i.
Negative 3i.
minus
Negative
3i
3i.
Minus 3i. Then
3i juga
3i.
Negative 3i.
minus 3i.
Minus 3i. So even though we have 5 zeros here, we only have 3 different numbers. As I said at the beginning of this chapter. This chapter, if you remember the chapter that we have 3 zeros, but we have only 2 numbers. I just have this. Same like this. 5 zeros, but only 3 numbers. Why? Because 3i is a zero of multiplicity 2. Multiplicity 2 means that appear 2 times. Another one appear 2 times. What?
minus 3i.
Minus 3i. Also, zeros of multiplicity 2. But 0 is 0 of multiplicity 1. Nah. So at the end, 5 as well. 5 zeros. Any questions? Polynomial px There's a complex zeros, 1 minus 2i. And then we need to find all zeros of this polynomial. How many zeros altogether for this polynomial?
4.
4 zeros. So given for us 1 0. From this 1 0, definitely we will know another 1 0. Why? Why we have from 1 0 here, we will have another 1 0. Why?
Conjugate.
Conjugate pairs theorem. So how to divide, what you want to divide is x minus 1 minus 2i, x minus 1 plus 2i. We want to know what is our denominator when we want to divide using long divisions. First, similar the examples, the first examples today, if you look. So this one can be written as x minus 1 plus 2i. This one, x minus 1 minus 2i. Expansions will give us what?
X minus 1 square.
X minus 1 square
minus x minus 1
x minus 1
2i
2i plus x minus 1
2i
plus
plus 4i square. Minus 4i square.
4i square. Right. So this one cancel. X minus 1 square minus 4i square is minus 1. So x minus 1 square plus 4. So what we have is expansions.
X square minus
2x plus 1 plus 4, which is x square minus 2x plus 5. Next, we want to find 2 more zeros. We already get 2 zeros, but we want to find 2 more zeros. And how to find 2 more zeros? How do we do? We get next to find 2 more zeros. What do we have to do?
Long division.
We have to do long divisions. So for x power of 4 plus 0x to the power of 3, because we don't have x power of 3, plus 17x square. Oh, we do right here. 4x to the power of 4 plus 0x to the power of 3 plus 17x square plus 14x plus 65. You divide by x square minus 2x plus 5. So what's first? What first? What's next?
For x power of 2.
So x power of 4x square 4
4x square.
Then multiply what we get for x square.
4x power 4.
X power 4, right. Minus
8
8, right? 8x power of 3.
Yes, sir. Minus x 8x power of 3 plus 20x power of 2.
Plus 20 x power of 2. So here 8x power of 3. You get it? 8x power of 3 here. What here?
Negative
Negative
x
3.
power of 2.
Minus 3x square. Then you bring down plus 14x. Now you divide. What do you get? What do you get?
Eight x.
Plus 8x. Multiply 8x cubed. Then minus
16x squared.
16x square plus
40x.
40x. Finish. Minus 3 plus 16. Very good.
$13x square
13x square
minus 36x
minus 36x.
no wrong
36.
negative 26
26x. To bring plus 65. So what you get?
Sir.
Plus 13. So 13x square minus 26x plus
65.
65. Finish. So our px can be written as x minus 1 minus 2i. 1. Another one, x minus 1 plus 2i. Another is 4x square plus 8x plus 13. So we try to factorize this part, right? In order to find two more zeros, right? We have 1 zeros here. Understand? Is that you understand? Any question? You have 1 zero here. This is one of the zero. You get 1 zeros here. Right. Look at that. Now please on your camera. Yeah. So you get the question. And the problem, you get 1 zero there. 1 zero here. Right. Any question?
No, sir.
So how many zeros from here?
2, sir.
2 zeros. So how to find these 2 zeros from here? To find these 2 zeros from here, we have to factorize this one. Or remember that this is quadratic. And this is quadratic. You can get the value using quadratic formula. By using quadratic formula, you can get the value of x. Because you cannot factorize this. Once you cannot factorize, use quadratic formula. You cannot factorize, you cannot using factor by grouping, you cannot use substitution like I showed, right? But don't worry, because you still can have the value of x here by using quadratic formula. Remember when we study equations, to solve quadratic equation, we can solve by 3 ways. Factorizations, complete square, quadratic formula. So one way is by using quadratic formula. Hopefully you still remember that quadratic formula is this. This is in your chapter 1 for equations. For the quadratic, 3 ways to solve to get the value of x. And now we want to get the value of x because we want to know all the zeros. So zeros here will be, what will be our zeros here? 1 minus 2i, right? 1 0. Another 0 is 1 plus 2i. Another 0 is some 2 values of x you obtain from here. You understand? So 2 zeros. Altogether, how many zeros?
4.
4 zeros. Because this polynomial is polynomial of degree 4. So 4 zeros. Right. Let's say px x power of 3 plus 4x minus 5. using Descartes' rule of sign and rational zero theorem, find all zeros of Px. So how many zeros? 3 zeros. So using Descartes' rules of sign here, Descartes' rules of sign is just to find how many positive and how many negative. Rational zeros theorem only to find the possible of zeros. Remember that Descartes' rules of sign and rational zeros theorem only apply for the real zeros. This polynomial might be contained of complex zeros. Try to get the zeros of this polynomial. You're supposed to get 1 minus 1 over 2 plus I minus 1 over 2 minus I. 3 zeros. You try. 3 zeros. 1, 2, 3 zeros. Only one real and 2 more complex. Complex must come in pair. Any questions? Right, your tutorial submission is tutorial 1 through WhatsApp. For tutorial 2, I will let you know. This week and this week, we don't have activities, meaning that no quiz or no tutorial. Next week also no quiz and no tutorials. And then quiz 2 will be on week 9. Currently, we are on week 7. Meaning that half of the lessons, half of part of the, because the lesson is 12 weeks. So we now in week 7, half already gone. Right. So I think I need to stop here because I have to do something of the process of vaccinations. This, right? So inshallah, we'll see you back on tomorrow at 11 o'clock, right? So in the meantime, you try this. So I stop here with Tasbih Kifara and Surah Al-As. Bismillahirrahmanirrahim.
Thank you, sir.
Thank you, sir.
Welcome.
Sir.
Thank you, sir.
Thank you, sir.
Welcome.